Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzuddin Syamil Rizal, and today I'm gonna show you how to solve a differential equation about growth and decay. First of all, we have to know what is growth and what is decay. In ODE, when we say about growth, it usually refers to a population growth, and it usually means we have to find the population increase at a rate of proportional to its size. And for decay, it usually refers to a radioactive isotopes such as plumbum, lead, or anything else. Using ODE, we have to find the decaying over time. Next, let's go to see what's the problem we have. For the first problem, the number of certain type of bacteria increase continuously at a rate proportional to the number present. If there are 100 present at a given time and 300 present after 5 hours later, how many will there be 10 hours after the initial time? How long does it take for the number of bacteria to double? So to solve this problem, first of all we have to define what's in the question. So we use PT for the amount of bacteria at any time. And for growth rate, this is usually the formula we use. dP over dt equals Kp, where K is a constant of proportionality. From the formula, we can integrate both sides. No, we have to. We have to integrate both sides, so it will be easier for the next step. So we will get P equals Ce or the power of Kt. And then from the problem statement, it is given that at the time 0, the population is 100. So we put it on the formula after we integrate it. So we have 100 equals C E K 0. Ce power K0. And E at the power of 0 is 1. So we got it. We put it right there. 100 equals C times 1. So we times it, we get C equals 100. And next we have to find K. From the question, we also know that at the time after 5 hours, the population increased to 300. So we put it on the same question, same formula. So we got 300 equals 100 E at the power of 5K. And for K we have ln 3 over 5. And we put it together, so we have P equals 100 E at the power of ln 3 over 5T. After we get the answer, we now can answer the question. For the first question is, we have to find the population after 10 hours. So we have to change the T to 10. So we will get P equals 100 times E on the power of ln 3 over 5 times 10. So we put ln on each side, so we will get P equals 100 times 3 on the power of 10 over 5, and we will get P10 equals 900. For the next question, we have to find the population when it's double. When it's double, the initial population is 100, so when it's double, we have to times 2, and we get 200. So P is 200. We put it on the equation. 200 equals 100 EKT. And then we divide the 200 by 100. So we get 2 equals exponent ln 3 over 5t. And then we can put ln on each side, on both sides. And we will get ln 2 equals ln 3 over 5 times t. And when we change the t to the other side, we will get t equals 5 ln 2 over ln 3. And the answer is 3.15 hours when the population is double. For the next problem is about radioactive decay. We look at the problem statement. The radioactive isotope of lead, Pb209, decays at a rate proportional to the amount present at the time t and has a half-life of 3.3 hours. If 1 gram of lead is present initially, how long will it take for 90% of the lead to decay? To solve this question, it's quite easy. We just have to use the same step as the growth rate problem. So first we have to define the amount of lead that at any time. So we put AT as the amount of radioactive isotope at any time. And then we have almost similar equation, which is dA over dt equals Ka, but this is where K is less than 0. And then we integrate both sides, and we have A equals Ce on the power of Kt. And then from the question, we know that the initial isotope is 1 gram. So 1 equals C times 1 is 1. So C is 1. And we have to find K and X. From the question, we know that the half-life of the isotope is 3.3 hours. So we put it at the equation, and we get K equals ln 1 over 2 over 3.3 hours. Then we put it together, and we have A equals E in the power of ln 1 over 2 over 3.3 times t. After we get the answer, we have to find the time for 90% of the isotopes to decay. Since it say we have to find the time after the 90% have decayed, so the remaining is 10%. So A equals 0.1. Say we put it on the equation, 0.1 equals E in the power of ln 1 over 2 over 3.3 times t, and we get t equals 10.96 hours. In conclusion, the bacteria population increased to 900 after 10 hours, and the population is doubles every 3.5 hours. Next, the amount of plumbum 209 decreased With a half-life of 3.3 hours, it takes around 11 hours for 90% of the lead to decay. This proves that ODE can be applied in everyday life with showing how to apply first order differential equation.